if you look at the second one here, you need to put it together with one log and then solve. And so if you'll remember your condensing and expanding rules, if I am subtracting, I'm going to put those together in one logarithm by using division. So I'm going to rewrite this. I'm going to have log base 4, and now I'm going to do x divided by that 9, and that equals -3. And then, like I said, you can either do base 10 of both sides. Here we're going to do base 4. Since we're already in log form, we're going to do exponential. We're going to say 4 and 4. It will cancel there. So we have x over 9 equals 4 to the -3. And then we will multiply both sides by 9. 4 to the -3, remember, is just 1 over 4 cubed. So you should be able to do that in your calculator. 9 divided by 64. And get that answer. So if a $26,000 sports car loses 15% of its value each year, when to the nearest tenth of a year will the car be worth $10,000? So our final amount that we have here is $10,000. We started with $26,000. Remember, for my formula here, I'm going to say 1 plus or minus. If it's losing 15%, what am I going to do there? Yeah, I'm going to say minus 0.15, and that's raised to the years. And that's actually what they're asking for. How many years? Well, we don't know, so that's what we're actually solving for there. That time is what we're solving for. We're going to divide both sides by that 26,000. And of course, we can just clear out all of those. You can reduce it as well. 5 over 13. So I have 5 over 13 equals 0.85 to the t. And this is where you want to do log of both sides to get it out of that exponent. Anytime the exponent is what you're solving for, you want to take the log of both sides. By doing that, we can drop this exponent in front here. So we have log of 5 over 13 equals t times the log of 0.85. And then we can just divide. And you can do all of that in your calculator. You should be able to say log of 5 over 13 divided by log of 0.85 equals my time. Later, in your calculator, you will get 5.879, etc. Nearest tenth of the year is right there, which is how we get our 5.9. So we've talked about an irrational number before. The most famous of the irrational numbers is pi. Irrational meaning it's non-repeating, non-terminating decimal. So it's just going to go on and on and on and on. As a decimal, it never ends, it never repeats. The next number that we talk about as being an irrational number that you're going to see rather frequently from this point on is the natural number e. This number is also irrational, meaning that that decimal 71828 keeps going. That's just what they've rounded it to. So 2.718 is around where they round it. You'll see that up in the function here. But it is a number. So when you see e written like this, it's not a variable. It doesn't change. It's just like pi. It is a set number. All right. In fact, if you look in your calculators, you will see above usually you have your log with 10 to the x above it. And then below your log, you have an ln with e to the x above it. That is the natural number e. So if you do that to the first power, you're going to get 2.71828. And as far as your calculator gives you those decimals, it will keep going. They tell you where it comes from. It comes from the limit as x keeps getting larger here and x keeps getting larger here. They found this is the number that it's actually approaching. So just like with pi, where they compared your circumference to your diameter, and they said, hey, every time we divide circumference by diameter, we get the same exact number, and it's 3.14. That's pi. So they kind of backed into pi, and they kind of backed into this with this particular equation. All right. What we found is this number is what they use when you do a limit. So when we think about limits, this is if we were to do something gradually versus something in a step. Okay, so we've done compound interest, but with compound interest, they say, hey, it compounds quarterly, right? So if it compounds quarterly, How many times does it compound a year? 4 times, right? That is a known number. 1, 2, 3, 4. We know exactly how many times it compounds, right? But that is like almost a step function. So like you're going to go to three months in the year, and then all of a sudden you're going to get compound interest. And then 3 months later, all of a sudden you're going to get compound interest. Okay. So that's kind of a stair step thought process, right? It's not like you gradually do it. When you have something that is compounding using this continual function, then it's not a stair step. It is continually increasing or decreasing versus a actual line in the sand where you can say, oh, I'm at March 1st. I get compound interest now. All right. Then I'm going to do June 1st. There we go. We get compound interest. This is actually something that's going to be continually and gradually going. So you can think of it like driving a car. You don't get in your car and you're at 0 miles an hour and then immediately you're at 60 miles an hour. That's not how this works, right? That would be a problem. So you can't do it, right? It's going to be a gradual thing. Even if your speedometer goes up by 1s or 5s, you're actually not going up by 1s and 5s. You're actually continually increasing that speed or decreasing that speed. And that's what you can think of when you can think of growth using your natural number. It is a continuous growth. It is not a stair-step type growth. And so the first thing we're going to do with natural numbers is we are just going to evaluate them. So on your calculator, just to make sure we all know how to use our calculator with E, you need to locate the natural log, the LN button on your calculator. And right above it, typically you have an E to a power, E to the X. All right. So you're going to have to use your shift or your second button or some button on your calculator to get above that. And you're going to have to do that. And so make sure that you know how to do like E to the second power. So make sure in your calculator you know how to use that E function. Typically, when you hit the E button, it looks like this. It's going to open kind of like that. And so it's going to automatically open parentheses. And they want you to just do E to the second power. So if you do E to the second power, you should get approximately 7.389, somewhere in there. With every base, the base E actually has an inverse as well. And that is your natural log. On your calculator, the button right below the one you just used looks like this, LN. LN. All right, so another way to think of LN is log base E. All right? So you actually have 2 logarithms that have an assumed base when you are using logarithms. You have this right here. When you do not see a base, the assumed base is a 10. And similarly, when you see it written like this, ln, that is also log, but that is an assumed base of E. All right, and so you're going to see those used all the time, all right? The log base 10 is very common when you use with in change of base, although you can actually use natural log for change of base, it doesn't matter. But then the other one that you're going to see, natural log, you're going to see this with continuous growth. And so that's what the type of problems we're going to be doing this particular section is continuous growth. It is called the natural logarithm function, and that is called the natural number E. All right, and so they've given you the graph of your y equals e to the x. You can see it's an exponential graph. It goes up really quickly. The inverse of that graph just flips across the y equals x line. Y equals natural log of x. All right, and so just like base 10 cancels out your common log, base e cancels out your natural log. And so we're going to use that in our equations with bases of e. So look at this next example. Find this. So a couple things I want to point out. If this is natural log, that's the same thing as log base e of e to the third. What do I know about bases and logs? What happens here? They cancel. So actually this whole thing is just going to equal 3. So when you have the natural log of e to any power, the natural log will always cancel out e. Always, right? So you don't have to put that in your calculator. If you have something like this though, you probably want to put it in your calculator. So what am I asking here? If I'm saying ln of 4.38 equals x, what I'm actually trying to find out is e to what power equals 4.38, right? And so that one you would need to do in your calculator. So in your calculator, you would do natural log. you would use that LN button. It's going to open parentheses. So you should have an LN button on your calculator. When you hit that, it's going to open parentheses, and you're going to put in the 4.38 close parentheses and enter. All right, and you should get approximately 1.477, somewhere around there. All right, so that is your natural log. So how is this going to help us? This is going to help us by helping us solve equations. So look at something like this. We've already been able to solve this using common log. You can also do this same exact thing with natural log, all right? You can actually do the natural log of both sides. You're going to get the same answer. So whether you use common log or natural log, you can still expand it the same way that you did before, moving that in front, and then solving just like you would. So your natural log and your common log will do the same functions. There will be times when we have to use my common log or have to use my natural log. But when you have something like this, you can actually do it either way. So whether you do this using a base 10 or a base E, you're going to get the same answer. And so this particular function, you could solve either way. You could use log base 10 or natural log and do your expanding and do your solving for your x. It doesn't matter. They're both going to do the same thing. All right, so I want you to try a couple of these using natural log. Solve using natural logs. To solve this using natural logs, you're going to just do natural log of both sides. Once you do that, you can move this over. And they actually set this up differently, but we're going to get the same answer. So 2x minus 1 is what I have here, times ln of 4 equals ln of 144. Divide both sides by that ln of 4. You get 2x minus 1 equals ln of 144 over ln of 4. I am going to add the 1 here, and then I'm going to multiply at the end, or divide at the end. So I actually have 2x equals ln of 144 over ln of 4 plus 1. They did some condensing here, that's why it looks like that. Divide both sides by that 2. And when you do this, it's going to be the same thing as when they did it this way. So just like your logarithms will help you expand or get rid of your, get your exponents where they need to be, getting a base is what's going to get rid of your natural log. You, just like we did with common logs and any other log, you need it down to 1 log before you get rid of it. So like A is already set up for me. I have this right here, and I already know my base of ln is E, so I'm just going to do a base E on both sides. All right? Bases cancel out bases. So I want to use whatever base this log is giving me, in this case, natural log. These two will cancel, so on the left I have just 5x, and on the right I have e to the second power. The most common mistake is that when people rewrite this line, they don't do e to the second power, they just write 2. All right, you have to do the same thing to both sides. And then I'm just really solving for x. So if I, in my calculator, put e squared divided by 5, I will get my answer here, which is, my head, don't worry. Yeah, you should get 1.4778. There we go. Better. The problem with B is you cannot immediately get rid of your natural logs here. You have to have only 1 before you use a base to cancel out a log. So before you ever start with canceling logs, we have to condense these. I'm going to start condensing with this coefficient. That's going to come up here. So I have the natural log of x squared minus the natural log of 5 equals 4. How do I condense subtraction? Division. So to get this to one base, I'm going to say x squared divided by 5. All right? And then I can get rid of my base, my natural log with my base. So I could say e to both sides there. That is going to cancel. I have x squared over 5 equals e to the 4th. This is where I'm multiplying by 5, by the way. Multiply by 5, I get x squared equals 5e to the 4th. How do I solve for my x? Square root, right? So I'm going to say the square root of both sides, right? In this case, I do say the positive and negative root of x is going to equal the positive and negative root of this right here. 5e to the 4th. The e squared can come out. You would have the square root of 5. So it's actually going to end up being a positive number, 16.5224. If we were to plug in a negative back in, we have a problem. This causes a problem for the negative root. So it's going to have to be the positive root there. So... about compounding interest, compounding quarterly, annually, daily, right? That's like a step. At this specific point, you're going to compound. This is called a continuously compounding function. And so we're not looking at a specific date and time where it compounds. We're saying it's a continuous function. It's not going to jump from one compounding time period to the next. It's going to compound continuously. This is one of the easiest functions to remember because people think it looks like a word. A equals pert, right? P is your principal. E is your natural number E, and your exponent is your rate times your time. All right, so this is continuously compounding. And you're going to see this used in science as well as in business, so you'd see it both places. Let's look at this first example here. Rob invests $2,000 in an account that accrues continuously compounded interest at 6% APR. What is the account balance after 3 years? And then how long will it take for it to grow to $3,000? So the first thing they're asking for is the account balance, the A. So we're just going to fill this in. We are looking for A. My principal is $2,000. I'm going to use my E. My rate is 6%, so I'm going to change that to decimal, 0.06. And we're going to multiply that by the time. All of that is in my exponent. And again, you can do all of this in your calculator. In your calculator, you're going to say 2,000. You're going to do multiplication. You're going to do that base e, which is above your natural log. It's going to open your exponent. So do 0.06 times 3 inside your exponent and then close. And this is dollars and cents. So we are always going to round dollars and cents to 2 decimal places. After 3 years, he will have approximately $2,394.43. So make sure that you can do all of that in your calculator. Continuously compounding interest. They're not actually asking for what it will be. They're actually telling you what they want it to be. So in this next part of this question, they have actually given us the A. The amount of the account balance will be $3,000. We're still starting with 2,000. Our base is E. We still have an interest rate of 6%, but now all of a sudden we're looking for time. So anytime what you're looking for is in the exponent position, you're going to use logs, okay? In this case, you're going to use a specific log. Yeah, I would get that eventually. There. Divide by 2,000. I wrote it right over here. There we go. How do I get rid of my E? Yeah, so this is where you want to use natural log because it would be crazy to use another log base. So we're going to use natural log of both sides, all right? On the right-hand side, it actually completely gets rid of it. The natural log of the E is going to get rid of the E, right? And so that's going to cancel out, and I have the natural log. You can put 3/2 or it's just 1.5, right? 0.06 times t. How then do I solve for t? What's my last step here? Yeah, so my t is going to be the natural log of 1.5 divided by 0.06. Rounded to 1 decimal place, you're going to get approximately 6.8 years. So when you're looking at word problems like this, you need to pay attention to what they've given you. It will grow to 20,000. That tells you that's what they want the account balance to be. It's really easy to figure out the rate. Those aren't usually the things we don't know what to do with. It's knowing whether they've given you the principal or whether they've given you the account balance. You need to pay attention to what you're solving for in the problem. All right, so I want you to try just a couple of these. These two.